Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 7 has been released, you know, right? So in this video I am going to discuss the solution of mock test 7. Okay, question number 151 to 180. If you haven't downloaded the question paper, please join the WhatsApp channel using the link which is given in the description box. Okay, yeah, let us start. Question number 151. A 6-pole generator with fixed field excitation develops an EMF of 100 volt, that is E1 is equal to 100 volt when operating at 1500 rpm, that is omega 1 equal to 1500 rpm. Okay, at what speed must it rotate to develop 120 volt, that is E2. Okay, E2 is 120 volt. E2 is 120 volt. So here we need to find the value of omega 2. Okay, we know that E is equal to NAB omega, right? So this question is came from electromagnetic induction, EY. Okay, so E, that is induced EMF developed, is equal to NAB omega. N is number of turns, A is area of the coil, B is magnetic field, omega is angular velocity. Okay, so E is directly proportional to omega, right? E is directly proportional to omega. So E2 divided by E1 is equal to omega 2 by omega 1, right? Here we need to find the value of omega 2, right? So omega 2 equal to E2 by E1 into omega 1. Now omega 2 is equal to E2, that is 120, divided by E1, that is 100, into omega 1, that is 1500. Here 100 will get cancelled. 120 into 15 is 1800. So omega 2 is equal to 1800 rpm. So the correct option is B. Okay, yeah, next question. Question number 152. A coil of N 100 turns carries a current I equal to 5 ampere and creates a magnetic flux phi equal to 10 to the power minus 5 Tesla meter square per turn. The value of its inductance L will be. We know the relationship between current, inductance, magnetic flux, right? So L into I, the relationship between inductance, current and magnetic flux, L into I equal to N into phi, right? So what we need to find here, we need to find the value of L. So L equal to N phi divided by I. Now L equal to N is 100 turns, right? Phi is 10 to the power minus 5 divided by I. I is 5. Now L is equal to, now solve this, you will get 0.2 millihenry. 0.2 millihenry. So the correct option is D. Okay. Next question. Question number 153. A transformer reduces 220 volt to 11 volt. The primary draws 5 ampere current and secondary draws 90 ampere. The efficiency of the transformer is. Okay. So here the transformer reduces to 220 volt to 11 volt, right? So that is EP, that is voltage in the primary coil, EP is equal to 220 volt, right? ES is equal to 11 volt. See here the transformer reduces 220 volt to 11 volt, that is step down transformer, right? Here the primary draws current 5 ampere, secondary draws current 90 ampere, right? So now efficiency of the transformer is equal to output power divided by input power. Okay, now eta is equal to output power is ES into IS, right? ES into IS, input power is EP into IP. Now ES is 11 volt into IS is 90 divided by EP is 220 into 220 into IP is 5, right? So 11 2s are 22, here 0, so 11 by 20, 11 into 20 is 220, right? So now 5 1s are 5, right? Then 4 remain, right? So then 8, so 18. Okay, now this will be 10 and 9. Okay, now which is equal to 0.9. Then efficiency is equal to 90% efficiency of the transformer. So the correct option is D. Okay. Yeah. Next question. Question number 154. The RMS value, that is root mean square value of potential difference V shown in the figure is. Okay. So this is the given figure, right? So we need to find the RMS value of the potential difference V, right? So RMS value V RMS root mean square is equal to root of integration of here T1 to T2 V square dt divided by integration of T1 to T2 dt, right? So this is the RMS value, right? Formula for RMS value of the voltage. Now here the voltage varies from 0 to T, right? Isn't it? Now V naught is the potential difference, that is V here V naught is from 0 to T by 2, right? The time is from 0 to T by 2. Then 0, then the potential is 0 from T by 2 to T, right? From T by 2 to T, isn't it? Now here V RMS is equal to root of integration of here the time 0 to T by 2, okay, 0 to T by 2 into V naught square into dt plus integration of T by 2 to T 0 dt, okay. So it will be 0 only, right? Divided by T, okay, 0 to T. Now here this will be 0 to T into dt, okay. Now V RMS is equal to, now solve this, you will get V naught divided by root 2, okay. Now the correct option is B. Understood? Yeah. Next question. Question number 155. In series combination of RL and C with an AC source at resonance, if R equal to 20 ohm, then impedance Z of the combination. The direct question, right? In a resonance circuit, inductive reactance is equal to capacitive reactance, right? Now impedance of the circuit Z equal to root of R square plus XL minus XC whole square. XL minus XC is 0, so Z equal to R, which is equal to 20 ohm, okay, 20 ohm. So the correct option is A, okay. Next question, question number 156. The range of the wavelength of the visible light. The direct question, right? It is from 400 nanometer to 800 nanometer. So it is given in angstrom. So 4000 angstrom to 8000 angstrom. So option B is the correct answer. Okay. Next question. Question number 157. A 2 centimeter tall object is placed 15 centimeter in front of concave mirror of focal length 10 centimeter. 15 centimeter from the concave mirror of focal length 10 centimeter. What is the size and nature of the image? Okay. So the focal length of the concave mirror is 10 centimeter. The position of the object is 15 centimeter from the concave mirror, right? So object placed between F and 2F, right? Isn't it? Object placed between F and 2F, right? So if object placed between F and 2F, then image will form beyond 2F, right? Image will form beyond 2F. So definitely the the position of the object beyond 20 centimeter, right? 20 centimeter from the concave mirror, right? So what is the nature of the image? The nature of the image is real and inverted, okay? So real and inverted. So option B and D both are eliminated. So we need to find the correct option between A and C. That's it, okay? Now we have eliminated two options, right? Okay. Now let us find V, okay? We need to find the size of the image, right? Size of the image, right? So magnification is equal to, magnification for mirror, concave mirror equal to V minus V divided by U, which is equal to height of the image divided by height of the object, right? Height of the object we know U, right? That is minus 15 centimeter, U equal to minus 15 centimeter, and we can easily find the value of V. How we can find V? By using mirror formula, 1 by F equal to 1 by V plus 1 by U, right? Find V, then we can easily find the height of the image, okay? Yeah. Now U we know, right? So let us draw a ray diagram. Okay. So the first one here, the ray which goes like this. Okay. Then the second one, second ray, right? Okay. Second ray which falls normally, and then parallel ray, right? It is a parallel. Okay, let us redraw the diagram. Okay. Here first ray, right? Okay, and then the second ray. Okay, somewhere here image will form, right? Okay, now okay, let's draw the arrows. Yeah, now this is AB, okay, and A dash, B dash. Okay, now apply mirror formula. Mirror formula is 1 divided by F is equal to 1 by U plus 1 divided by F. Sorry, 1 by U plus 1 by V. 1 by U plus 1 by V. Now, what is the focal length of the concave mirror? It's minus 10 centimeter, right? Why? Because the focal length lies in front of the concave mirror, right? So, 1 divided by minus 10 equal to 1 divided by U is minus 15, right? Minus 15 centimeter plus 1 by V. Now, 1 by V is equal to 1 divided by 15 minus 1 divided by 10, right? Now, 1 divided by V is equal to, take 1 by 5 as common. Okay. Now, this will be 1 divided by 3 minus 1 by 2. Okay. Now, 1 by V is equal to, here 1 by 3 minus 1 by 2 is minus 1 divided by 6, right? So, 1 divided by 5 into minus 1 divided by 6. So, the value of V equal to minus, sorry, here the value of V equal to, yeah, correct, minus 30 centimeter, right? Here the value of V is equal to minus 30 centimeter. Okay, now we can easily find the height of the image, right? Yeah, magnification M equal to minus V by U, which is equal to height of the image by height of the object. Now minus of minus V, okay, sorry, minus V, that is minus of minus 30 centimeter, divided by U, that is minus 15 centimeter, is equal to height of the image divided by height of the object, that is 2 centimeter. Okay, now height of the image is equal to, here 15 2s are 30, right? Minus into minus plus, again here the minus sign is there, right? So this will be minus 2, right? So minus 2 into 2 centimeter, that is minus 4 centimeter. So minus 4 centimeter. Okay, so what is the meaning of negative sign here? The meaning of negative sign is the image is inverted. Okay, image is inverted. So the correct option is A, 4 centimeter and real. Next question, question number 158. A ray of light passes through an equilateral prism such that the angle of incidence is equal to angle of the emergence, I equal to E, and the latter is equal to the 3 by 4th of the angle of prism, that is E is equal to 3 by 4 times A. The angle of deviation is, okay, so we know the relationship between angle of deviation, angle of prism, angle of incidence, angle of emergence, right? That is delta plus A is equal to I plus E, right? Now angle of deviation, delta is equal to, here I equal to E, right? Isn't it? So I can write 2E minus A, right? 2E minus A. E is 3 by 4 times A, right? Delta is equal to 3 by 4 times A minus A, right? Delta is equal to 3 by 4 times A minus minus A. Here 2 is multiplied to 3 by 4 times A. 2 is multiplied to 3 by 4 times A. Now 2 2s are 4, right? Now delta is equal to 3 by 2 A minus A. Now 3 by 2 minus A is 1 by 2A, right? Delta is equal to 1 by 2 times A, right? Delta is equal to 1 by 2 times A. So we need to find the angle of deviation, right? Isn't it? So here delta is equal to 1 by 2 times A, right? Yeah. Angle of prism is, what is the angle of prism? Here the angle of prism is 60 degree. Why? Because the prism is equilateral prism, right? The prism is equilateral prism, 60 degree, 60 degree and 60 degree. Angle of prism is 60 degree, right? Isn't it? A equal to 60 degree. So delta is equal to 1 by 2 times A, that is 30 degree. So the correct option is B. Okay. Yeah. Next question. Question number 159. A light travels in two media, A and B, with speeds 1.8 into 10 to the power 8 meter per second and 2.4 into 10 to the power 8 meter per second respectively. Then the critical angle between them is. Okay. So what is the condition for critical angle? The condition for critical angle, sin C is equal to refractive index of A with respect to B, right? Refractive index of A with respect to B. That is refractive index of B with respect to A, right? Refractive index of B with respect to A. Now what is the refractive index of B with respect to A? Mu B divided by mu A, right? Mu B divided by mu A. Mu B is refractive index of the B, that is C divided by VB, right? Divided by C by VA, right? So C will get cancelled. Now VA divided by VB, right? Now sin C, that is critical angle, is equal to VA. VA is 1.8 into 10 to the power 8 divided by VB is 2.4 into 10 to the power 8 meter per second. Okay. Now here 3.6, right? So here 0.6, right? 0.3 into 0.6, right? Sorry, here 0.3 into 6 is 1.8, right? 0.3 into 6 is 1.8. And 0.3 into 8 is 2.4. Then 2 3s are 6 and 2 4s are 8, right? Now C equal to sine inverse of 3 by 4. Okay. The correct option is B. Okay. Yeah. Next question. Question number 160. A thin prism of angle 15 degree. See here, 15 degree is a small angle. Small angle, right? Made of glass of refractive index mu1 equal to 1.5 is combined with another prism of glass of refractive index mu2 equal to 1.75. The combination of the prism produces dispersion without deviation. That is, the total deviation delta t equal to 0. Okay. So what is the total deviation? That is deviation produced by the first prism plus deviation produced by the second prism is equal to 0. Okay. The angle of the second prism should be, okay, we need to find the angle of the second prism, right? Angle of the first prism is given, that is A1. Okay. So for small prism, deviation is equal to mu minus 1 into A. Okay. How we got this formula? We got this formula from this equation, mu into sine of A plus delta divided by D, or delta minimum divided by T divided by 2. Okay. Sine of A plus delta m divided by 2 divided by sine of A by 2. Okay. So for small angle, sine theta is approximately equal to theta, right? So then this becomes A plus delta m by 2 and this is A by 2. Solve this, you will get this formula. Okay. Now come to here. Now delta 1 is equal to mu1 minus 1 into A1, right? Plus delta 2 is mu2 minus 1 into A2, which is equal to 0. Okay. Now A2 divided by A1 is equal to minus of mu1 divided by 1 divided by mu2 minus, okay, minus of mu1 minus 1 divided by mu2 minus 1. Okay, a2 by a1 is equal to minus of mu1 minus 1 divided by mu2 minus 1. Okay, a1 we know, right? Mu1 is 1.5, mu2 is 1.75, right? Now a2 is equal to a1 minus of a1 is 15 degree, right? 15 degree into mu1 minus 1, that is 1.5 minus 1, 0.5 divided by mu2 minus 1, that is 0.75. Okay, 0.5 is 1 by 2. Okay, 0.75 is 3 by 4. Okay, now 1 by 2 by 1 by 4 is 1 by 1 by 2, right? Now this becomes 1 by 3 by 2. 1 by 3 by 2 is 2 by 3. A2 is equal to minus 15 degree into 2 by 3. Okay, now this is 5, 3 5s are 15, so A2 is equal to minus 10 degree. Here, what is the meaning of negative sign? The negative sign indicates that the other prism, or the position of the other prism is inverted. Okay, so this is how the combination looks like. Okay, 15 degree and 15 degree, sorry, minus 10 degree. Okay, it is inverted. Now the correct option is B. Okay, yeah. Next question, question number 161. If two waves represented by y1 equal to 4 sine omega t, y2 equal to 3 sine omega t plus pi by 3 interfere at a point, the amplitude of the resulting wave will be about. Okay, we need to find resultant amplitude, right? Resultant amplitude A is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Understood? This is the formula we have to use. A1 square plus root of a1 square plus a2 square plus 2a1 a2 cos phi for resultant amplitude, right? So what is the value of a1? A1 is 3, sorry, a1 is 4, right? A2 is 3, right? So what is the meaning of phi? Phi is phase difference. What is the value of phase difference? Phase difference is pi by 3, right? Phase difference phi equal to pi by 3, right? Now substitute the values. A is equal to root of a1 square. A1 square is 4 square, okay, plus a2 square. A2 square is 3 square plus 2 into 4 into 3 into cos pi by 3. What is the value of cos pi by 3? 1 by 2, right? So 1 by 2 will get cancelled. Sorry, 2 and 2 will get cancelled. Now A is equal to root of, here 4 square plus 3 square is 25, right? So 25 plus 12. Okay, so 25 plus 12 is 37. So A equal to root of 37. Okay, root of 37, which is approximately equal to 6. So the correct option is B. Okay, yeah. Next question, question number 162. Green light of wavelength 5460 angstrom is incident on an air glass interface. If the refractive index of the glass is 1.5, the wavelength of the light in glass would be. The simple one, right? So how to solve this? We know that the refractive index of the second medium with respect to the first medium is equal to refractive index of the second medium divided by refractive index of the first medium, right? So what is the refractive index of the second medium? Refractive index of the second medium is C divided by V2 divided by mu1. So mu1 is refractive index of the air, right? Refractive index of the air is 1 only, right? Then here mu2 divided by mu1. Mu2 divided by mu1 is equal to 1.5, right? 1.5 is equal to C divided by V2, right? 1.5 is equal to C by V2. Okay. So what we need to find here? We need to find the wavelength of the light in glass, right? Okay. So let us find V2. V2 is equal to 1.5 divided by C, right? 1.5 divided by C, right? Sorry, C divided by 1.5. C divided by 1.5. Okay. Here V2 is equal to C divided by 1.5. So V2 is equal to C is 3 into 10 to the power 8 meter per second. So 3 by 1.5 is 2. So 2 into 10 to the power 8 meter per second. So this is the velocity of the light in glass, right? So we need to find the the wavelength, right? Wavelength of the light in glass, right? Okay. So here velocity of the light is directly proportional to lambda, right? When light travels from one medium to other medium, frequency do not change, right? Frequency of the light does not change. So V is directly proportional to lambda, right? Now V2 divided by V1 is equal to lambda 2 divided by lambda 1, right? V2 by V1 is equal to lambda 2 by lambda 1. So V2 is 2 into 10 to the power 8 divided by V1 is 3 into 10 to the power 8 equal to lambda 2 divided by lambda 1. Lambda 1 is 5460 angstrom, right? Now here 2 divided by 3, right? 10 to the power 8, 10 to the power 8 will get cancelled. Lambda 2 is equal to 2 by 3 into 5460 angstrom. Okay. So now 3 ones are 3, right? Now 3 8s are 24, right? So now 3 2s are 6, then 0, right? Now 0, 4, 6 and 3. So 3640 angstrom. So this is the value of lambda 2. So the correct option is A. Okay. Yeah. Next question. Question number 163. The figure shows a plot of photocurrent versus anode potential for photosensitive surface for 3 different radiations. Which of the following is correct statement? Okay. The first statement in option, the statement says curve 1 and 2 represent incident radiation of same frequency. Okay, so this is the curve 1. Okay, curve 1, this is curve 1 and curve 2. So these two represents incident radiation of same frequency. Correct, right? Incident radiation of same frequency. Here this is the retarding potential, right? Isn't it? Retarding potential depends on the frequency, right? Isn't it? So these two represent the same frequency, correct, but different intensities, correct, right? Photocurrent depends on the intensity, right? Here photocurrent is different, right? But these two curves meet at the same point, that is the retarding potential, right? That is the frequency is same, intensity is different. So option A is correct. Okay, option A is correct. Let's check B, C, D also. B says curve 2 and 3 represent incident radiation of different frequencies and different intensities. 2 and 3 represent incident radiation of different frequencies. Yeah, this is correct. Incident radiation of different frequency and different intensities. Wrong. Same intensity, right? These two are same intensity, right? Not different intensity. So option B is wrong. Option C. Curves 2 and 3 represent incident radiation of same frequency having same intensity. 2 and 3 represent incident radiation of same frequency. Wrong. Different frequency, right? Why? Because two different retarding potential, right? So option C is wrong. Option D. Curves 1 and 2 represent incident radiation of different frequency. Wrong. Same frequency, right? So option D is also wrong. The correct option is A. Okay. Question number 164. Which metal will be suitable for photoelectric cell using light of wavelength 4000 angstrom? Okay, here wavelength of the light is 4000 angstrom. The work function of the sodium and copper are respectively 2 electron volt, 4 electron volt. Okay, so we need to find the here suitable metal for photoelectric effect. Okay, so let's find for sodium. Okay, here the work function of the sodium and copper is given, right? Isn't it? Now work function phi is equal to hc divided by lambda naught, right? What is lambda naught? Lambda naught is threshold wavelength, right? So let us find the threshold wavelength. If the value of threshold wavelength is lesser than the wavelength of the incident light, okay, then that metal is suitable for photoelectric effect, okay. If it is not, that is lambda naught is greater than incident wavelength, okay, incident light wavelength, so then that metal is not suitable for photoelectric effect. So lambda naught is equal to hc divided by phi, okay. Now here for sodium, okay, for sodium, here lambda naught is equal to h into c, right? H into c divided by phi, right? So h is Planck's constant, 6.66 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 5. Phi is for sodium, here phi is 2 electron volt, 2 into 1.6 into 10 to the power minus 10 to the power minus 19 coulomb, right? So this is approximately 2, right? 2 will get cancelled, right? This is rough mathematics, okay. So lambda naught is equal to here 10 to the power minus 19 into 10 to the power 8 by 10 to the power minus 19, that is 10 to the power 27, okay. 10 to the power minus 34 into 10 to the power 27 is 10 to the power minus 7, right? Lambda naught is equal to here 6.66 into 10 to the power minus 7, okay. Lambda naught is equal to in angstrom 6660, approximately equal to, okay, angstrom. See here, incident light, wavelength of the incident light is lesser than the threshold wavelength of the wavelength for sodium, right? So sodium is not suitable for photoelectric effect, right? So let us check for copper, okay. So sodium is eliminated, right? Let's check for copper. So this is for sodium, okay. So for copper, here for copper, lambda Cu is equal to Hc, that is 6.66 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 4 electron volt, right? 4 into 1.6 into 10 to the power minus 19, right? So anyway, this will be 10 to the power minus 7, right? Now here this is approximately equal to 2, right? Then 1 by 2. Next, this will be 3, 3, 3. So threshold wavelength for Cu, that is copper, is approximately equal to 3333 angstrom, right? Isn't it? 3333 angstrom. Now approximately equal to, okay, this is not an exact value, approximately equal to 3333 angstrom. So here the threshold wavelength for copper is lesser than the wavelength of the incident wave, right? So this metal, that is copper, is suitable for photoelectric effect. So option B is the correct answer, okay. C and D are wrong. Yeah, next question, question number 165. In Bohr model of hydrogen atom, let Pe represent potential energy and Te represent the total energy in going to a higher level, okay. So let us write the equation for kinetic energy, potential energy and total energy. From that only we will get to know, okay, whether it increases or decreases as you go higher level. Now the potential energy is equal to minus E square divided by 4 pi epsilon naught into Rn, okay. Rn is the radius of the nth orbit, okay. And here this is Pe, right? Not U, okay, Pe. What is the kinetic energy? Kinetic energy is E square divided by 8 pi epsilon naught Rn, right? Now the total energy is equal to kinetic energy plus potential energy, right? Now total energy is equal to, now substitute these formulas, these two formulas, okay, here, then you will get minus E square divided by 8 pi epsilon naught Rn, okay. Now total energy is equal to minus 2 times potential energy, right? Minus 2 times potential energy, okay. Now as you go higher level, the potential energy decreases or increases? Actually it increases, right? Potential energy increases as you go higher level. Why? Because of the negative sign, the potential energy increases, right? If it is positive, then it would be decreases, it would have been decreases, right? Isn't it? But here, because of the negative sign, the potential energy increases, right? So if potential energy increases, then the total energy will also be increases, right? So potential energy increases and total energy will also be increases, right? So option D is the correct answer, okay. Potential energy increases, so total energy will also be increases. Next question. Question number 166. An alpha particle of energy 5 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. Here, this is the uranium nucleus, fixed uranium nucleus. This is the alpha particle, okay. So it is scattered through a 180 degree by a fixed uranium nucleus. The distance of closest approach is the order of, here this is the distance of closest approach r, okay. So we need to find the distance of closest approach, okay, in the order of, okay. Here at the distance of closest approach, the kinetic energy of the alpha particle converts into potential energy of the okay. So now the kinetic energy is equal to half mv square, right, which is equal to potential energy. Potential energy is Zd square divided by 4 pi epsilon naught into r. We need to find the value of r. R equal to Z into E square divided by 4 pi epsilon naught into kinetic energy, okay. Now r equal to, now substitute the values, okay, you will get r equal to 5.3 into 10 to the power minus 12 centimeter. So it's in the order of 10 to the power minus 12 centimeter. So the correct option is A, okay. Now substitute the values, you will get this answer, okay, approximately equal to, yeah. Next question, question number 167. Rutherford atomic model was unstable because nuclei will break down, wrong, electrons do not remain in orbit, correct, right? So why? Here electrons moving in a circular path, right? This is nucleus, electrons moving in a circular path, right? So when electrons moving in a circular path, according to classical theory and electromagnetic theory, it radiates or it emits electromagnetic radiation, right? Electromagnetic radiation. It emits electromagnetic radiation. That is, electron loses its energy, right? Isn't it? Electron loses its energy. Eventually, it will fall into the nucleus, right? So that makes unstable, right? That makes atom, okay, unstable. That makes atom unstable. So option B is the correct answer, okay. Next question, question number 168. The mass defect in particular nuclear reaction is 0.3 grams. The amount of energy liberated in kilowatt hour is, okay. So energy in joule, E equal to delta m into c square, Einstein's energy mass equation, right? Isn't it? E equal to, here the mass completely converted into energy, right? That is 0.3 grams completely converted into energy. So E equal to delta m into c square. So E is equal to 0.3 grams, that is 0.3 divided by 10 to the power 3 into c square, that is 3 into 10 to the power 8 meter per second. Now E is equal to, here this will be, now this is the energy, right? Isn't it? This is the energy, sorry, 3 into 10 to the power 8 whole squared, right? Now this is the energy, right? Now divide, E divided by 3.6 into 10 to the power 6. We need to convert it into kilowatt hour, right? Isn't it? So 0.3 into 10 to the power minus 3 into 9 into 10 to the power 16 whole divided by 3.6 into 10 to the power 6, right? Now here E is equal to, solve this, you will get 7.5 into 10 to the power 6 kilowatt hour. Okay, so the correct option is D. Yeah, next question, question number 169. A nucleus disintegrates into two nuclear parts which have their velocities in the ratio 2:1. Ratio of their nuclear sizes will be. Okay, so now this nucleus is disintegrates into two parts, right? Two parts which have their velocity ratios. Here v1 divided by v2 is equal to 2 by 1. Okay, we need to find their sizes. Okay, ratio of their sizes. Okay, that is, we need to find the ratio of the radius of these two nucleus. Okay, here initially this nucleus is at rest, right? Now we disintegrate into two parts, right? These two parts are moving, right? So apply conservation of momentum. Why we are applying conservation of momentum? Because there is no external force acting on our system, right? Now what is the conservation of momentum? Here conservation of momentum is initial momentum 0 is equal to final momentum m1 v1 plus m2 v2. Okay, so in magnitude m1 v1 is equal to m2 v2. Okay, so v1 divided by v2 is equal to m2 by m1. v1 by v2 is equal to m2 by m1. Okay, so m2 divided by m1 is equal to 2 divided by 1, right? m2 by m1 is equal to 2 by 1. We know that mass is directly proportional to volume, right? Volume is directly proportional to r cube, right? So now r2 by r1 is equal to 2 by 1 to the power 1 by 3, right? So r2 is to r1 is equal to 2 to the power 1 by 3 is to 1. So the correct option is A. Okay. Question number 170. If the total binding energies of deuterium, helium, iron, uranium nuclei are 2.22, 28.3, 492 and 1786 mega electron volt respectively, identify the most stable nucleus of the following. So here these are the given nuclei, right? So we need to find the most stable nuclei, right? So how to find the most stable nuclei? Take the binding energy per nucleon values, right? So then compare it. So whichever the nucleus has the higher binding energy per nucleon value, so that nucleus is more stable. Okay, yeah. So first one for deuterium, okay, binding energy per nucleon for deuterium. Okay, now binding energy per nucleon for deuterium, okay, Be, not Bh. Okay, so it is Be, binding energy per nucleon for deuterium. So here, which is equal to 2.22 mega electron volt, 2.22 mega electron volt divided by nucleon. What is the value of nucleon here? 2, right? That is atomic number, right? Sorry, mass number, right? 2, mass number, okay, not atomic number, mass number. Now which is equal to 1.11 mega electron volt, right? Isn't it? Okay, now for helium, binding energy per nucleon for helium. Okay, now binding energy of the helium is 28.3 mega electron volt, right? Divided by what is the nucleon number? 4, right? For helium it's 4, right? That is mass number is 4. So this is 4. So now solve this, you will get 7.08 mega electron volt. Okay, 7.08 mega electron volt. So let's find binding energy per nucleon for iron. Binding energy per nucleon for iron. Okay, so what is the binding energy of the iron? So that is 492, right? Divided by nucleon number is 56. Now solve this, you will get 8.78 mega electron volt. Okay. Next, binding energy per nucleon for uranium. Binding energy per nucleon for uranium, which is equal to 1786 divided by nucleon number is 235. Now solve this, you will get 7.06 mega electron volt. Sorry, 7.6 mega electron volt, not 7.06. Okay, 7.6 mega electron volt. Okay, 7.6 mega electron volt. Now compare here for deuterium 1.11, right? For helium 7.08. Here the maximum value for iron is 8.78 mega electron volt, right? Here iron has the maximum value, binding energy per nucleon value, right? Maximum binding energy per nucleon value. For uranium it's 7.6, right? So iron has the maximum value of the binding energy per nucleon. Okay, so therefore iron is the most stable nucleus. Okay, iron is the most stable nucleus. So option A is the correct answer. 171. At absolute zero, Si acts as insulator. Okay, insulator. So the correct option is C. Yeah, question number 172. In semiconductors, at room temperature, the conductor band is completely empty. Wrong. The conduction band is partially empty and the valency band is completely filled. Okay. So option B says the valency band is partially empty. Wrong. It's completely filled. Conduction band is partially filled. Okay. The valency band is completely filled, correct, and the conduction band is partially filled, correct. So option C is the correct answer. Okay. Next question, question number 173. Reverse bias applied to junction diode increase the minority carrier current. Wrong. Okay. So if you apply the reverse bias to a junction diode, what happens? The potential barrier rises. Okay. There will be a current because or due to the minority current carrier. Okay. So option A is wrong. Option B lowers the potential barrier. Wrong. Option B raises the potential barrier. Correct. Increases the majority carrier current. Wrong. So the correct option is C. Question number 174. A long straight wire is turned into a loop of radius 10 centimeter. If a current of 8 ampere is passed through the loop, then the value of the magnetic field and direction at the center C of the following shall be close to. Okay, so at this point, that is at C, we need to find the net magnetic field, that is magnetic field due to the straight wire and magnetic field due to the circular loop, right? So B, that is net magnetic field at C, okay, is equal to BC is net magnetic field at C equal to magnetic field due to the coil plus magnetic field due to the wire. Okay, so now let us find the magnitude of magnetic field due to the wire at C and the direction also. Okay, and then magnetic field due to the coil and direction also. Yeah, let us find magnetic field, or let us write magnetic field due to the straight wire. Magnetic field due to the straight wire, okay, BW or B wire at C, okay, is equal to mu naught I divided by 2 pi r, right? Mu naught I divided by 2 pi r at C, the magnetic field due to the straight wire, right? So what is the direction of the magnetic field at C? The direction of the magnetic field at C is into the plane, right? Isn't it? Or inward, right? Into the plane or inward direction. Understood? So how we got the direction? Use the right hand thumb rule. Okay, your tip of the fingers represent the direction of the magnetic field at C, right? And your thumb represent the direction of the current, right? Your tip of the finger directing into the plane, right? So magnetic field is into the plane. Yeah. Next, magnetic field due to the coil. magnetic field due to this coil, the circular coil, is mu naught I divided by 2r, right? So what is the direction of the magnetic field at C due to coil? So it is outward from the plane, right? Outward from the plane. So net magnetic field at C is equal to here mu naught I divided by 2 pi r, it is into the plane, plus mu naught I divided by 2r outward from the plane. Take outward direction as positive, okay? Outward direction as positive, inward direction as negative, okay? Outward direction as positive, inward direction as negative. So I'm going to use another slide, okay? Here BC, that is magnetic field at the center C or at point C, is equal to mu naught I divided by 2r minus mu naught I divided by 2 pi r. Okay. Now magnetic field at C is equal to, take mu naught I by 2r as common, into 1 minus 1 divided by pi, right? Now B at C is equal to mu naught is 4 pi into 10 to the power minus 7. The value of current is 8 ampere divided by 2 into R. R is 10 centimeter. That is 10 into 10 to the power minus 2 into 1 minus 1 divided by pi. That is 3.14. Okay. Now solve this. You will get BC is equal to, here BC is equal to 3.4 into 10 to the power minus 5 Newton ampere per meter. Okay, Newton ampere per meter. This is the value of magnetic field at C, right? So the correct option is B. Okay, Newton per ampere meter. Okay, sorry, Newton per ampere meter. This is Newton per ampere meter, not Newton ampere per meter. Okay, now what is the direction? The direction is outward, right? The direction is outward from the plane. Okay, so the correct option is B. 175. Turpentine oil is flowing through a tube of length L and radius R. The pressure difference between the two ends of the tube is P. The viscosity of the oil is given by eta is equal to P into R square minus X square divided by 4VL, where V is the velocity of the oil at a distance x from the axis of the tube. The dimensions of eta are. Okay, so we need to find the dimension formula of eta. That is coefficient of viscosity, which is equal to P, that is pressure. What is the dimension formula of the pressure? The dimension formula of the pressure is dimension formula of F divided by dimension formula of A. That is dimension formula of force by dimension formula of A. What is the dimension formula of force? M L T to the power minus 2, right? Dimension formula of A is L square. So 1 by A is L to the power minus 2, right? Into dimension formula of R square minus X square, that is L square, divided by dimension formula of V, that is L into T to the power minus 1, into L. Dimension formula of L is L only, right? Here L square, here L square will get cancelled. L square into L to the power minus 2 will get cancelled, right? Now L will get cancelled, right? Now dimension formula of coefficient of viscosity is equal to M L to the power minus 1 T to the power minus 1. Okay, M L to the power minus 1 T to the power minus 1. So option D is the correct answer. Okay, next question, question number 176. If a car covers 2/5 of the total distance with v1 speed, yeah, this is the total distance, okay, x. Now 2/5 of the total distance, that is 2/5 times x with speed v1. Okay, next 3/5 of the total distance, okay, 3/5 of the total distance with v2, then the average speed is. We know that average speed is equal to total distance divided by total time or time taken, total time taken, right? Now V average is equal to total distance. Total distance is here x divided by time. Time is distance divided by velocity, right? Here it covers 2/5 of the total distance with velocity v1, that is 2 divided by 5 into x divided by v1 plus 3/5 distance, 3/5 of total distance with v2, so 3/5 x divided by v2, right? Here anyway x will get cancelled, right? So v average is equal to, now solve this, you will get 5 v1 v2 divided by 3 v1 plus 2 v2. Okay, so the correct option is D. Okay, next question, question number 177. The velocity of the projectile at the initial point A is 2i cap plus 3j cap. Here velocity at the initial point A is 2i cap plus 3j cap. Okay, so 2 represents horizontal velocity, okay, 3 represents vertical velocity of this velocity, okay, vertical velocity 3 meter per second. Okay, its velocity at point B is, its velocity at point B is, at this point we need to find the velocity. Here the direction of the horizontal velocity is same, that is towards right. And what is the direction of the vertical velocity? It's in downward direction. So therefore at B velocity is 2i cap minus 3j cap, okay, unit meter per second. So option B is the correct answer. Okay, 2i cap minus 3j cap meter per second. Okay, yeah. Question number 178. The maximum speed of a car on a road having turn of radius 30 meter if the coefficient of friction between the tires and the road is 0.4 will be. Okay, so here this is the car. Okay, it is moving on a circular track, right? So this is the front view. Okay, front view. Let us draw the free body diagram. Okay, here N is the normal force acting on this car. Okay, here the car is moving on a circular track, right? So car experiences centrifugal force, so it is radially outward. The centrifugal force is radially outward, right? So that is mv square divided by r, right? The car stays on the track, right? Isn't it? The car stays on the track. So why? Because there is a friction between the tire and the road, right? There is a friction between the tire and the road. It is balanced by centrifugal force. So what is the direction of the friction? The direction of the friction is towards the center of the circular track, right? That is mu s into n, right? Mu into n, okay? Mu into n. Mu into n. So we need to find the maximum velocity or maximum speed of the car on a road having a turn of radius 30 meter. Okay, now mv square by r is equal to mu n, right? N is mg, right? So mv square divided by r equal to mu into n is mg, right? M will get cancelled. So v equal to root of mu g r, right? V equal to root of mu into g into r. Now substitute the values. What is the value of mu? The mu is 0.4, right? What is the value of g? G is 9.8, right? What is the value of r? R is 30 meter. Now solve this, you will get 10.84 meter per second. So the correct option is B. 179. A block of mass 2 kg collide with identical stationary block head on elastically with velocity of 20 meter per second. So this is the block, it collides with this block elastically with velocity 20 meter per second. That is, when the collision is elastic, what happens? It will exchange the velocity, right? The mass of these two objects are same, So it will exchange the velocity. That is, after the collision, this block will have velocity 20 meter per second and this block will have velocity 0 after the collision. Okay. After the collision, second block collide with the third block of mass 2 kg initially at rest if they collide head on perfectly inelastically. Okay, perfectly inelastically. That is, coefficient of restitution is 0. Okay, coefficient of restitution is 0. Then the velocity of their combination will be. Okay, so velocity of their combination, right? So here we can conserve the momentum, right? Why? Because there is no external force acting on our system, right? So in inelastic collision, we can conserve the momentum, but we cannot conserve the energy, right? Okay. Now apply the conservation of momentum. Initial momentum is equal to final momentum. Initial momentum is momentum of this block plus momentum of this block. So what is the momentum of this block? 0. What is the initial momentum of this block? That is 2 into 20, 40 kg meter per second is equal to final momentum. Final momentum is mass of the both blocks into velocity v. What is the mass of the both blocks? 4 kg into velocity v. So v equal to 10 kg meter per second. So, sorry, 10 meter per second, okay, not 10 kg meter per second, 10 meter per second. So the correct option is C. Okay. Yeah, next question, question number 180. At T joint is formed by two identical rods A and B, each of mass m and length L in the xy plane as shown. Okay, so this is the given diagram, right? Its moment of inertia about the axis coinciding with rod A. Here, this is the axis, okay? Moment of inertia of the axis coinciding with rod A. This axis, right? So moment of inertia of the about axis coinciding with rod A, I is equal to, here moment of inertia of the rod A, so that will be 0, right? Plus moment of inertia of the rod B about this axis, so that will be ml square divided by 12. So I equal to ml square divided by 12. That's it. Okay, direct question. So option B is the correct answer. Okay, thank you so much. If you love this video, please like and share, and if you want to watch more such kind of video or such type of video, please subscribe. Thank you.